I got 5.
Okay. And let me just work that through with you.
Negative
So-
5. Negative.
Okay. All right. So drop that over here to the side. So 2 times 3 is 6. Now you can do like all the multiplication division together. So you can put a 4 here like
Yeah.
that. You don't have to wait, but you want to be careful here that you don't do too much in one line. So now whenever you have addition and subtraction, you just do that left to right. So 3 plus 6 is 9
9.
minus 4 is +5. Now that's what you said first. Why did
Oh,
you change your answer? What do you think was the reason for that?
because I thought that the 9. Oh, okay. So the 9 was a positive 9 and the 4
That's
was a
right.
negative 4. And I thought that a negative and a positive equals a negative, but the positive is a larger number, so
That's right.
that sign takes over and it's a +5.
That is said perfectly, and that's the kind of thinking you need to do these problems. Let's try some more here. Let's go 4 minus 3 divided by 1 plus -2 times 3. Okay. So again, you always do multiplication and division before addition and subtraction.
-5.
-5 again. All right, so 3, what is 3 divided by 1?
3.
Okay, and what is -2 times 3?
-6.
Okay, so a couple ways to write this. You can write plus -6, or you could just make it -6. Either is good. So
Oh,
now,
okay.
now your answer is correct. 4 minus 3 is 1 plus -6, or like I said, you could write it as, maybe put that in blue here in case you want to look at that later, is that you could look at this as 4 minus 3 minus 6, which is 1 minus 6, which is -5.
Mm-hmm.
And like
Okay.
you said, your answer is -5 there. Good. So is it clear that you do multiplication division before addition and subtraction?
Yes.
Okay, so we're building our order of operations. We're laying a great foundation here. So the next one is that you always do exponents before multiplication division, before addition and subtraction.
Yeah.
Okay, so I'll give you an example here. 1 minus 2 to the 8th plus 3 squared. I'm sorry, not 2 to the 8th. That would be really large. Let's not do that. All right. So we might need a quick review of like exponents. So 2 to the 3rd means 2 times 2 times 2.
Mhm.
So you take the base and multiply by itself, however many times are here. 2 times 2
Yeah.
times 2 is,
6.
try again.
6.
That's the
Wait,
2,
what?
2 times 2 is 4.
Oh, okay, I got that. And then for 8.
So it's really important that you distinguish between what you said first and what the correct answer is. What you gave is the most common wrong answer. And we're going to do a bunch of these so that you'll get familiar with it. But
Okay.
this becomes 1 minus 8. Now 3 squared means 3 times 2. So I want you to
9.
stare, yeah, which is 9. But I want you to stare real hard at the difference in these. 2 cubed means 2 3 times. 3 squared means 3 2
2
times.
times. Yeah.
Okay. So yes, this is +9. And now you just have addition and subtraction. So you do them in the order you see. So give that a try, please.
Okay. Um, 2.
-7 plus 9 is 2. Very good. All right, so let's do a few more here. Let's go 5 squared divided by 5 plus 6 squared divided by 12. Okay,
Okay.
so you always do exponents before multiplication and division, before addition and subtraction.
Yeah.
So I want you to first tell me the value of 5 squared and 6 squared, please.
Okay. Don't hit me.
Can you tell me what 5 squared is?
25.
Okay, and how about 6 squared?
36.
Okay, so it's kind of like precedence. You have to say, okay, I've got division, addition, and division. I do multiplication, division before addition, subtraction. So you first divide, then you add.
Okay, I got 3.
For which one?
Oh, well, for the whole answer.
So what is 25 divided by 5?
Oh, okay. 25 divided by 5 is 5.
And 36 divided by 12?
3.
Okay, so add these together.
8.
8. All right, let's try another one. Let me know when you're ready.
I'm ready.
Okay. Let's go 4 squared minus 3 squared minus 2 squared plus 1 squared.
Okay. Four.
Okay, so your answer is 4. So 16 minus 9 minus 4 minus plus 1. Is that what you have?
Yeah.
All right. So 16 minus 9 is 7. Minus 4 plus 1. 7 minus 4 is 3. Plus 1 is 4. Very good. Okay. How are you feeling about these?
Good.
I like that. I like hearing that. Okay. So a couple more exponent things to think about here. What is 1 to the power of 5?
1.
It is 1. What is 1 to any power?
1.
Okay. How about any number to the 0 power? Do you remember that one? Maybe
1.
you haven't seen that. It is 1. Good. Really good. Okay. That might come up. I'm not sure. All right. So let's do one more here. Let's do a couple more. Let's do 5 minus 3 squared plus 2 minus 2 to the third minus 6. All right, and then we'll do this, and then we'll do a new problem. We'll add to this after this one, but give this a shot,
Okay.
please.
Okay. I got 4.
Let's take a look here. 5 minus 9 plus 2 minus 8 minus 6. Does that look like what you have?
Yes.
Okay, so now it's addition, subtraction, just go left to right. So that's minus 4 plus 2 minus 8 minus 6. Minus 4 plus 2 is minus 2.
Yeah, I missed
Minus,
that.
okay, what did you write?
I did a +4 instead of a -4. So
So you got 6.
no.
So are you
Yeah.
still using the whiteboards? Like Mama told me
Yes.
you guys, okay, so well, here's what I recommend. I would recommend erasing everything below whatever, wherever this is, and then try to keep working it out from there.
Okay. Okay.
That's the benefit of using the whiteboard, is you can kind of get a feeling for.
Okay. I still got 4.
Okay, so minus 2 minus 8, they're both negative.
Yeah.
That
So
means the
that'll
answer
be
is negative, but
positive.
then you add the
Oh.
numbers together.
Okay. Okay. That's the part I messed up on then. So do you want me to redo that part?
Yeah, yeah, or actually you can
Okay.
just talk me through it. What is minus 10 minus 6?
-10 minus 6. So you would add, but keep the sign. So 16, -16.
You got it. Okay. All right, so we got some time left here. Let's introduce the last one. So parentheses, you do those before exponents,
Okay.
before you do add
Multiplication and
multiplication, division, and then addition, subtraction. So
yeah.
but this is where it gets really complicated, because let's just say I gave you a problem like 3 plus 5 minus 4 minus 3. But then I put parentheses right here.
You would do 3 times 5 and then 3 times 4,
No,
right? 'Cause
there's an addition here. This is addition.
oh,
Is
okay.
that not clear, or do I need to make that larger, that sign?
Yeah. Sorry, I couldn't
It,
see it. I was looking
okay.
at the board and then I looked up quick.
All right. So
Okay.
in this problem, like if there were no parentheses, you would add first, but here now you're forced to then subtract first.
Yeah, yeah, yeah.
Okay. So this would be 3 plus 1. Now
One.
you can now, this is what you have to know, is when you can drop parentheses. You can drop parentheses when there's no more operations inside. Like if you just
Okay.
have a single number, you can drop the parentheses.
Okay.
So it's really 3 plus 1 minus 3.
Yeah.
All right, so take it from here. Tell me what you come up with.
Four or wait, one.
So there's 1. Now, in this problem, it actually would have given you the same result with or without parentheses, but here's where it doesn't. So when we start mixing multiplication, division, addition, subtraction, so let's say we have 3 times 2 plus 4 times 1. Okay. Now, as soon as I put parentheses in here, you have to do this first.
Yes.
Okay. What is 2 plus 4?
6.
6. Okay. And then can we drop the parentheses? And if so, why?
Yes.
Why?
Yes,
Why can we
because
do
there's
that?
no more problems in it. Like I don't know what the word you used was.
There's no more operations inside.
Yes, operations.
Okay, good. So now you can do the multiplication that you see here. 3 times 6 times
3
1.
times. Okay. 18.
Your answer is 18. Okay. So your focus has to be on what's going on inside parentheses. Okay. So here's a problem for you to try. I'll
Okay.
put this in front of you here. And go ahead and take a look at that.
Okay.
I know these numbers inside here get a little large when you
It's
multiply, but
okay.
it's still doable.
Yeah. I got 90.
Okay, take a look here. 17 minus 3 is 14. We don't need the parentheses because we're all done. 14 minus 6 is 8. Now you have multiplication and subtraction. You do multiplication first. That's
Yes.
112. Subtract 22 is 90. Very good. Okay. Let's try another one here. I'm just gonna throw in a little wrinkle. When I say
Okay.
that, I mean it's slightly different than what you've been doing, but I think you're understanding. So let's just give it a try.
Okay. I got 218.
That is correct. Good. Really good. Okay. So I'm gonna put some more challenging problems in front of you here as we kind of close out here in the last couple minutes. Let's say this one, it's not meant to be difficult, but let me just put something in front of you here.
Okay.
Okay. So this is your like total, do you understand question, because it's got everything. It's got parentheses. It's got exponent. Actually, let me throw this in front. It's got multiplication, division. It's got addition and subtraction. What do you do first?
You do what's in the parentheses.
Okay,
First.
so what is minus 3 plus 5?
8.
Try again.
-8.
Try
Or
again.
just 8. 8.
It's not 8 or minus 8, unfortunately.
Oh.
You've got one positive and one negative.
Oh, okay. It's 2.
It is 2. Now, are we done with,
No.
I'm sorry, can we drop the parentheses?
Not yet.
So kind of not, right? Like
Yeah.
it's
Because you
better to
still have
keep,
another thing to do.
yes. So what is the thing to do there?
You do 2 to the power of 2
Okay, what is that?
with 4.
Very good. All right, let me throw another problem in front of you. This may be our last one for today.
Okay.
There we go. All right, let's give that a try and let me know what you come up with.
Okay. I got 111.
Really close here. Tell me what you did first.
So first I did what's in parentheses. So I did 6 plus 4, which was 10. And then you have to leave the power of 2. And then
Okay.
I did plus, and then I did what's in the other parentheses, and I did 10 plus 11, which was 21, divided by 2, which I got.
Problem is though, you've got to do division first. So inside parentheses,
Oh, okay.
inside parentheses resets.
So should I redo it?
Well, it's 10 divided by 2, which is
5.
5. 11 plus 5.
16.
It is 16. And then you don't need the parentheses anymore.
So then 116.
Yes.
Okay.
Very good. All right. So we're going to stop here for today. If you want to let your sister know, I'm ready for her. And
Okay,
I'll,
Victoria. Okay. Bye. Hello.
Victoria, how are you today?
Good. How are you?
Good. So last time we were working on greatest common factors. I don't know if you remember us doing that or not.
Yeah, I do.
Do you need me to post the divisibility rules for you, or do you feel like you still remember them from the other day?
You can post them.
Okay, give me just a moment to get back to where I've got those. There's
Okay.
divisibility rules up to say 20, and you can find those on the internet. I've got them up to like 10, I believe. And then most of them are kind of intuitive once you get down there. So if you can't tell, I'm stalling because I don't have the visitor rules open, and now I do. So here we
Yeah.
go.
Bye.
All right, so here are the divisibility rules. There's actually a divisibility rule for every number. So 2, it's even. That means it ends in 0, 2, 4, 6, or 8. 3, the sum of the digits is divisible by 3. That just means it divides by 3. Now 4, we haven't really talked about 4, and the reason is because it's 2 twice. If you can divide by 2 twice.
Uh-huh.
Okay, that's why it's not there. Plus, it's not prime. The first one is prime, second one is prime, 5 is prime. And what we do is we break these numbers into a prime factorization, a factor tree, if you will. Okay. So last time I had you work on a number of problems here. Let me have you try one to start here.
Okay.
I want you to give me first the factor tree from prime factorization of each of these numbers, please.
Okay. So for 30, is it 2 times 3 times 5?
All right, so yes, so you can always check that is 2 times 3 times 5. I mean, that's kind of the order operation stuff I was working with your sister. 2 times 3 is 6, 6 times 5 is 30. Yes, that's correct. So now do the same thing for 42.
So I got 2 times 3 times 7.
2 times 3 times
7.
7. Okay, now to find the GCF, what do you do?
You bring down what they both have. So like
Yes.
2 and then 3. So I got 6.
6, very good. And so what that represents, it's the largest number that goes into both.
Okay.
So let me have you try another one here. So go ahead and find the GCF for me, please.
So for 15, I got 3 times 5. And
Okay, I
for
agree.
33, I got 3 times 11.
Okay, keep going. So what is the GCF?
3.
It is 3. Good. All right, now let me give you another problem here. I want you to find the GCF of 7 and let's go 25.
So for 7, I got 1 times 7. And for 25, I got 5 times 5.
Is there any overlap?
What?
Is there any overlap? Any of the numbers that are the same?
Yeah, 5 times 5.
No, they've got to be the same on for each of them.
Oh, no.
No, there's no numbers the same. So this has no GCF. So this is in math, and you've learned this. There are exceptions. Okay, and
Okay.
this is an exception. There's no number that goes into both. Now you could argue that like 1 goes into both, but 1 is not a GCF.
Oh,
Is that okay?
yeah.
Okay. So let's try another one here. Let's try the GCF between 45 and 110.
Okay, so for 45, I got 3 times 3 times 5.
Okay.
And for 110, I got 2 times 5 times 11.
Okay. Is there any overlap? Any numbers that are the same in both?
5,
Okay. So what is your GCF?
5.
Very good. All right. Okay. Now you can also do a GCF for 3 numbers. So something like 10, 12, and 20. So could you come up with the GCF for these 3 numbers, and then we'll move on to something else.
Okay. So for 10, I got 2 times 5.
Okay, keep
For
going.
12, I got 2 times 2 times 3.
Okay, and for 20.
I got 2 times 2 times 5.
Now this time the number has to be in all three.
So 2.
Yes. So your GCF is 2. All right, so here's what I'm gonna do here. I'm gonna put some problems in the here for this. You can consider these homework. We're not done for today, but like we're done with GCF. So if you want, if you have time, maybe you do the odds or the evens, whatever you want for the lesson. But, let's move on to now what are called, and it's I mess this up all the time. I interchange these least common multiple, or LCM. All right. Now,
Mhm.
let's just say I wanted the least common multiple between 2 and 3. Okay. So here's how this works. You take the number 2 and you start finding all of its multiples, 2, 4, 6, 8, 10, 12, and you actually go on forever. And then you just do the same thing for 3, 3, 6, 9, 12, and you go on forever. Now, common means they're the same. So do you see how the 6 and the 6 are the same and the 12 and the 12 are the same?
Yeah.
Which is the least?
6.
Which is the smallest?
6.
6. So your least common multiple here, is 6. Okay. Because 12 is a multiple, but it's not the least one.
Okay.
Do you follow that or not? You can
I
say, hey,
do.
Matthew, that's totally unclear. No, don't understand it.
I do.
Okay. Now you might think you might wonder, why are we doing this, or how is this even related? Well, let's look at something else. Let's look at like 10 and 8. So we want the least common multiple of 10 and 8. So again, you take that 8, you start writing out all the multiples of 8. And this is your multiplication. This is your, okay. And then you start writing all the multiples of 10.
So would it be 40?
Okay. Now, this way we're doing right here works really well for 2 numbers. It also works well if these numbers are fairly small. Okay. But this is not the right way to do it. Making a list is not the right way. It's slow, take a while. What if you miswrite one? So here's a better way. I want you to do the prime factorization, the factor tree for 10 and 8, please.
Okay. So for 10, I got 2 times 5. And for
Okay.
8, I got 2 times 2 times 2.
All right. So to find the least common multiple, you generally start with the smaller one, okay? Smaller number.
Okay.
So you start with smaller number, you say, okay, it's a 2 times a 2 times a 2. So you've consumed all of those, okay? Then you go to the other number and you ask yourself, do I already have a 2?
Yeah.
Say that again.
Yes.
Yes, you already have a 2. Do you have a 5?
No.
So you add a 5 in there.
Oh, okay.
Does that make sense?
Yeah.
Now, what is 2 times 2 times 2 times 5?
40.
40. Is that our least common multiple?
Yeah.
It is. It is. A little yawn there. I know this is really exciting. So this is the better way, and this is the way we're going to do this. Okay, so let's take another one here. Let's say we want the least common multiple of 9 and 15. Okay, so to do that, first give me the prime factorization of each of those, please.
So, okay. So for 9, 3 times 3, and for
Okay, and for 15?
3 times 5.
Okay. All right. Now you start with the smaller one, which is smaller, 9 or 15.
9.
Okay, so you say, okay, I need a 3 and a 3. Then you look at the next one and you ask yourself, do I already have a 3?
Yeah.
But do I have a 5? So what is 3 times 3 times 5?
45.
It's 45. Good. Okay. So let me give you one to try here. Let me see let's go 6. I want you to find the least common multiple between 6 and 16.
Okay.
No, sorry, that's not a good one. I apologize. Try not to make the numbers too large. Also make them reasonable here. Let's go 14.
Okay. So for 6 would be 2 times 3, and for 14 it'd be 2 times 7.
Okay, so go ahead and start with a smaller number and tell me what you come up with.
42.
Okay. So your least common multiple is 42,
Yep.
and that is correct. Now, the same thing applies to 3 numbers. Okay, so let's say I wanted you to find the least common multiple of 2, 6, and 9.
Okay. Would it be 6?
Nope, nope. So you've got to do a factorization of each of these. What is your factorization?
Oh. For 2, I got 2 times 1.
Which is 2. 1's not a prime number.
Oh,
How about
okay.
for 6?
2 times 3.
Okay,
And then for 9, 3 times 3.
9 is what?
3 times 3.
Okay, so start with the smallest number.
Okay.
So you start with 2. Then you go to the next grouping of numbers and you add to it anything that you're missing.
Okay. So 2 times 3.
Okay, and then you go to the next one and you say, what am I missing? Do I have a 3?
Yep.
Do you have another 3?
No.
Okay, so what is the least common multiple?
18.
Yes. Now, if we just made a list here, if we just made a list of 2, 6, 9, okay, and went 2, 4, 6, 8. So we got the one for 6, but we need 9, 10, 12, 14, 16, 18, 12, 18, 18. See how we stumbled on it this way, but this always works
Okay.
the way here. Is that okay?
Yeah.
All right. Let's have you try another one here. So the problem would be phrased like this. It would say to find the least common multiple of 2 numbers here. So go ahead and give that a try, please. So I just want your final answer.
I don't know if this is right, but I got 45.
It is correct.
Oh,
Okay, we're gonna do a couple more here. They will get more difficult. It's just, we're trying to build up to, grab, it's actually this one. Give this a try, please.
okay. Is it 105?
It is 105. Perfect. All right. So let's see here. Let's go, go ahead and give this one a try, please.
Okay.
What are you doing on this one?
Good. I got 72.
It is 72. You are correct. All right. So here's what I'm gonna do here. I'm just gonna put a few problems on, again, of these type. If you want to practice, you can. And we are gonna close out here for today. So we'll pick up here on Wednesday at 11 o'clock. And that is it here. So let me go ahead and stop the recording.